Alright, hello. Hopefully everyone's doing alright today. Yeah, I'm a little bit late to my own stream, so whoopsies, but here we are. This is day 31 of setting compilers every day until I land a compiler role. Yeah, last time I numbered it wrong, so whoops, my fault. Yeah, we're gonna be doing the leetcode and then we're gonna continue the mem to regis stuff. So, yeah. Today's another one of those exhausting days, but I mean, we bounce back. That's always how it goes. Let me sign in real quick, sorry. Okay. Okay, sort vowels in a string. So we have a string. Yeah, so we permute it to get a new string such that consonants are in the same place and the vowels are sorted. Oh, okay. Okay. Oh, okay. So we have to sort them in non-decreasing ASCII order. Okay. Sure. So, yeah. That's an interesting problem. I mean, the thing that immediately I think of is just like a heap. We just stick all the vowels on the heap and then we reconstruct the string by popping off the heap. We could also just like stick them onto another string and then sort, I think. Yeah. So, yeah. Yeah, let's give this a shot. Yeah, people are back on campus now, so people are a little bit loud around. Okay. So we want each character. What's good, MD? Welcome here. So for each character, we just make a set even, or like a unordered map. I guess the fastest way to find a vowel is just if we literally make a set or a map or something. So let's make a set of yeah, and then we should probably just use a heap or something. Because I feel like that'd be easier to just like less messy to sort rather. So yeah. Unordered set. How's the job hunt? It's definitely going. I failed an interview yesterday, so unlucky, but I guess there's nowhere to go but forward. Okay, so you have an unordered set. Actually, map is key value pairs, while set is just keys. Actually, you know what I could do? I could actually do an unordered map. So char to int. So this will be vowels. Yeah, I'll make it. I'm sure of it. It was my first interview in a while, so it was I definitely went into it way more nervous than I should have been. And I spent like 40 out of the 50 coding time minutes just on the first problem, so it was like really bad. But yeah, I guess that's part of why I'm doing LeetCode here, so I can get better at this sort of stuff. And yeah. Actually, yeah. The idea here is this might be one of the few times where a just straight up map could make sense, because it's sorted. So we can, yeah, we should be able to just iterate through that even. Iterate through it and then it will be in order. So C++ is vowel. What? What the hell? Wait, people are doing like crazy shit for this. Yeah. It reminds me of like the I don't know if y'all have heard of this, but like the quick like fast inverse square root algorithm. There's like a really funny image. Yeah. So we have yeah, that's the video. I don't want to show that, but you should watch the video. If you haven't, just like look it up on YouTube. It's really cool, but just evil. So we have a float, and we cast it to a long yeah, we cast it to a long, and then we do whatever this is. It's, yeah, there's a lot of like crazy undefined behavior stuff that occurs here, but yeah, that is the fast inverse square root. So yeah. So when I was like looking at this, that was just in my mind. Yeah, we might just have to make a map or something. Yeah. So we will need another hash map. Maybe a map is slow, actually. Okay. So we want... At this point, we may as well just use a... whatchamacallit? We may as well just use a vector at this point. I guess we can try a couple different implementations. Let's just give this a shot. So we have an unordered set of available vowels. So this is A, E, I, O, U, and then big A, all the big ones. Yeah, so we have those. Actually, I shouldn't use map. This is low-key way too slow. Let's just use a vector. Yeah, so we have that, and then if available vowels, non-decreasing does mean yeah. So either increasing or same as previous. So if contains, I recently learned, exists. So let's just run that. And we want vowels in S. Yeah. Yeah, exactly. So this we should push back. Is it faster just to do this and then sort? Well, let's see what the topics is. Sorting. Okay, well, I guess we're gonna sort. Let's push back C, and then yeah. So that's that loop, and then we want to sort that. Bubble sort is slow. Screw bubble sort. I keep typing stood like I'm writing real code. A heap would actually just make this so much easier. Why am I doing it like this? Let's do a heap. Let's just do a heap. So it's a priority queue. It's what we want. I need to remember the interface for this. So we have push, and we have push, top, pop. Okay, sure. Let's just make this cur, so I have less typing. We don't need the sort anymore. If vowels got C, then we want to add cur dot top, and then res dot pop, not res, cur. And then otherwise, we want to add the current character. And then we can just return. So yeah, that should be reasonably brisk. Oh, something's wrong. Does it sort them in the wrong order? Yeah, okay. We need a different comparator. Because we're sorting it backwards. So where's the constructor? We want stood greater. So int, we need to feed it a vector. So we have char, stood, vector, not stood. So we have a vector, and then we want greater. Is that a thing? Like that? Greater char. Surely this works. Yeah, okay. Let's see how slow this is compared to everyone else. Oh, it's really slow. Why is this so slow? Okay, well... okay. Alright. So what do the fast people do? Counting sort. Yeah, okay. So the sort is slow. Wow. Okay, well, first let's get rid of vowels. So we want return C equals A. We can just do some really gross math here. Yeah, just give me a second. What? Okay. Let me just do this. And then this saves the overhead of set lookup, I guess. Supposedly this is faster. Yeah. Let's try it with just this for now. Let's see how much faster this is. I really hope this is faster. It'd be really awkward if it wasn't. Okay, well it's a little bit faster, but not really. Okay. So then what does this do? What is a faster way to do this? String will only have 10 different characters, yeah. Counting sort. So you know the 10 characters, iterate over the 10 vowels in ASCII order. Okay, so we store frequencies, that makes sense. Oh, okay, I guess that makes sense. Okay. So then how does this... Whoa. We're doing some really crazy stuff here. Okay, so this is like low-key the ugly way to do it. Yeah, okay. Yeah, so it's just like... Yeah, I really don't like this problem because I feel like the technically correct way to do it is also like the uglier way to do it. So, yeah, so let's make a, once again, an unordered map because it's faster. Let's make this a little bit less ugly. What's good, y'all? Welcome to the stream. Static const expr, let's make this a string sorted. This is... Do the big ones come first? The output... Yeah, the big ones come first. So we have... This is EIO. And then... Yeah, that ugly thing. So if this is a vowel, then we want to... Wait. What's a compiler? It is a program that converts one language to another. So a program that, for instance, converts C code into x86 assembly, for instance. Or a program that converts Python into C, for instance. Wait, how do they do this? Alright, that's the wrong one that I'm looking at. This stuff makes sense, and then... Wait, this is crazy. This is such an ugly solution. But it's also faster. Yeah. What we're doing, I am doing the leetcode the fast way, because I did it the slow way before. I don't like this way though. This like hurts my soul writing this code because it's like so ugly. Yeah. Yeah, so if it's not a vowel, then we can just add the character. Otherwise, then we need to do some other really gross stuff here. So we would want to take if vowels at sorted at I is greater than 0, then we can use that one. What's good, Niraj? So we would want to... Hey Skittles, welcome back to the stream. So we'd add... I hate the solution. I actually hate the solution so much. This is such an ugly solution. And then we can break this loop. And then we should just be able to return. Can we like keep a persistent counter? The vowels sorted I. Yeah, okay. Alright, let's see how much faster this is compared to the previous way I did it. Still piss slow. How do these do it again? Oh, that's really cringe. Okay. Okay, yeah, okay, I'm not gonna take more time beating a dead horse there. Yeah, that's leetcode. Yeah, it's like the pretty way to do that problem is to like, the pretty way is just to like use a priority queue. And you just like, if it's a vowel, you stick it on and then like you iterate through it again, and then if it's a vowel, you just pull it off. The optimal way to do it would be just to like, first avoid the sort, and then second use a data structure that is like not like dummy slow. So like vector is probably the fastest here, just like direct indexing. Hash map is probably second, and then like everything else is like comparatively slow. So the optimal solution like uses a vector for retrieval, and then we just index by the vowel, and then like we just like compare against like the available vowels, and then we just pull the next one off with like a lot of random, just like a bunch of extra lines of code, which like fair enough because it's fast, but like it's really annoying. But anyway, enough of me ranting about the leetcode. Yeah. So last time we started mem to reg a little bit. So if we go here, we finished building out like all the pass stuff and all the pass manager stuff. Oh, what's going wrong here? Oh, right. This should be... Where is rerun if invalid? This takes a program, so this would be MIR. Okay. So that's still good. Yeah. So what we started was mem to reg, which is a pass. And this pass basically takes all of the stack variables we've created, and then it turns them into like actual variables. So we have like, currently when we generate this middle end IR, we don't have like real variables because we have to preserve static single assignment, which is like really annoying to, because like if we were to just do it with variables, we would have to do it twice because we would still need this sort of pass to like rebuild it after other optimizations run. So it's easier to just kill two birds with one stone and just have the pass handle that for us instead of having to implement it separately for the lowering to MIR. How do you split screen that fast? It's VS. Yeah. Okay. So what we do in the front end is we basically just make every variable a stack variable. And then we just say like, okay, we can let this other pass clean it up later. So I like started scaffolding it out. I was a little bit lazy to finish implementing that because I was quite tired and I needed food. So yeah, here I would need to, I guess, start building this. So we want like DFS through basic blocks, I guess. Yeah, the first one should always be the entry block. So, oh, it's like, it feels like I'm preparing for interviews again. So we need to, let's make an adjacency. We don't need to make an adjacency list. We can just add the first basic block to the work list. So we want a, oh, Q is a thing. Does Q use a different interface than, or like, is its underlying implementation just a deck? Because if they are just, if they're just a wrap around a deck, I may as well just use a deck. Q is a restricted list. Interesting. I'm like very curious about this actually, because it feels just like there's no reason to not use deck. Yeah, I guess this is literally just yeah, this is literally just a deck. C plus Q wrap deck. Oh, I see. Okay. So let's just use deck. Yeah, let's just use deck. So this takes a basic block pointer. Deck is double-ended queue. So it's like a combination of a stack and a queue. So you have push front, push back, and then you have pop front, pop back. So we want, oh, what type is this, actually? This is basic block, okay. Okay, so we have deck. And this takes basic block. Hello, Janine. Yeah, we need that. We can call this work list. Oh, what the? Okay. Oh, I need to import deck. Okay. Yeah, so if you look here, we have push back, push front, and then we have pop front, pop back. So we want to push back f dot get basic blocks, and then we want 0. We want the first basic block. Right, so we have so while it's not empty, we want to, how do we do this? So let's just, we can just have a placeholder to process for now, and then let's just do, so cur is work list dot front. Can I just do this? Is that a thing? This shouldn't make a copy, right? Surely. Yeah, this should be fine then. Right, we need like this. Okay, that looks reasonable. Yeah, okay, this seems correct. Can't wait till we start implementing algos. Yeah, that's where the fun is. A lot of people kind of dislike it. I always found that like that was kind of the enjoyable part of data structures. But then again, I'm also like the person that enjoys writing compilers in my free time. So like, sure. Any advice for people starting out? The big thing is just make things with your time. Just like get started with projects, even if like you don't necessarily know all the code yet, or like if you don't know how to do things. That's just a perfect reason to learn the things that enable you to do them. I had to implement dexters and prims, and there's overlap with that. Yeah, I feel like usually data structures and algorithms get kind of bundled together into one class. What's good, John? Are you live every day? Yes, I am live when the LeetCode daily resets every day. And then we can just worklist.pop back. Yeah. Okay. And then we want to. Does my basic block have any like descendants to it? I think that is one thing I managed to neglect to implement. That would live in here. All right, let's see. Yep, I forgot that there need to be descendants. Okay. Unlucky. So let's add that real quick. So we want a vector of basic block pointers. How long have you been programming for in general? Just a while, I guess. Since I started college, I guess. So it's like, what, almost 4 years now? Just starting my compiler class in college right now using Flex and Bison. Ooh, fun. So we have, what do we call this? I want to call this descendants. Yeah, we can call it that for now. Okay. What are you working on right now? I am working on a compiler from C to x86-64. And the part I'm working on right now is, I guess, SSA construction. So there's like a whole lot of theory behind that, but the rough explanation of what SSA is instead of reassigning variables, you kind of just create new variables. And that makes analysis easier for optimizations. And it actually just makes a whole lot of things easier. The only annoyance is that creating it is a little bit slow. And it takes like effort. Yeah, so what do we need? We need to we should do get descendants, I guess. This should be a vector of, yeah, we can just steal this even. Let me just look up if there's a more proper term for this. How do you recommend not burning on programming? a lot of it is just pacing yourself. If you don't feel like writing code, then like don't necessarily force yourself to. Although if you are willing to still write code and enjoy it, then I think that says a lot about your passion and I guess how much discipline you have. There's not really any good term to describe descendants instead. Anyone got any suggestions anywhere? Just call it next even. Let's just do this for now. Do you code better while streaming or not streaming? Honestly, I code better without streaming. And like, the reason is pretty simple. I guess I'm just like less narrating my code. Granted, I think the process of narrating my stuff does help me, it does help me, I guess, think things through, but the process is just like a little bit slower. Any advice on getting a software internship as a math undergrad with little experience? You should do whatever you can to get experience, whether that is like finding work somewhere or working on personal projects, just anything to buff up your resume. Okay, so we can skip process for now, and then for these optimizations will run after the semantic analysis. So I guess we're doing I guess like the 3-tier compiler design. I'm not sure if like your class has covered that yet, but usually there's like a front end, a middle end, and a back end. The back end handles code gen to assembly, and the front end handles like processing like the language constructs. But what the middle end does is it's basically what handles all the optimizations. So semantic analysis is like long gone. That's like way back in the front end. Here we've already gotten to the middle end code, and then yeah, so we have like our middle end language, and then we just have a bunch of optimizations that we run on it. And when all of those are done, then we lower that to assembly. And the idea is that makes it more maintainable and more extensible. Personal project recommendations, there's plenty. You can definitely Google a bunch. I don't really think my list is particularly great, but I will say that it's really helpful to, I guess. Oh wait, I can't do DFS, huh? Oh wait, we might have to do some like topological sort of stuff, but yeah. If you run into a problem in like your daily life and you're like, damn, I could write a program to solve this, that's a great personal project to work on. So like one of my first personal projects that was like not terrible was just like our debate team was like taking a lot of time between rounds just to like refresh pages and sort of figure out where everything is. And it's like, that took up a lot of time, so I was like, I could write a bot to automate that, for instance. And that was pretty good actually, just to like get my foot in the door for my internship this past summer. That combined with like research as well. If your school has a bunch of faculty that I guess do research in some way, and you meet like their prerequisites, I think it's good to at least talk with them, see if you can do anything for them. So we want cur.descendants. Wait, I forgot the. Was it CC? Aha, it was. Okay. I remember from yesterday now. Yeah, I think. Honestly, I would even start applying now, Skittles. A lot of roles fill up really quickly, and September and October are like prime recruiting season. And like I know like it sucks having like an incomplete project or just like not having an ideal resume, but a lot of the roles come out like before November at least. So yeah, ideally just like they're kind of concurrent. Just remember that five applications a day is 35 a week, and that makes 150 a month. So yeah, that is how I think about it, at least. Yeah, let's hear about it, Big Bro. So each descendant. Oh, we might have to. Oh, okay. Okay, we're gonna do a little bit of topo sort, which really sucks. This really sucks. This is like the LeetCode. This is the interview problem I had yesterday that I just like completely bonked my head over. It's literally what I'm doing right now. This exact thing I'm writing right now is literally the interview problem that I spent 40 minutes on yesterday and failed the interview because of. All good, all good. It's all sour grapes. Did I spell this wrong? So this is basic block and int. Let's just use big numbers because I've been using big numbers always. C student, do we not need it? Okay, I guess we don't. I made a compiler called Helium. It's a Rust compiler. Ooh, nice. I was not at Spur Hacks. Multi-thread quiz app. I think that is also a pretty good project. I don't really think what it is matters as much as just like, for now, just that like you have passion about things. Just like if you have a project that like you're excited to talk to an interviewer about, I think that's the big thing. This should be in degree. Yeah. What's missing? Whoops. There we go. Yeah, concurrent programming / parallelism is all really cool. It's all really difficult, but it's like playing with fire because like when you get it right, it just feels so good. Like everyone loves linear speedup. Any tips on how to understand this while being new to compiler theory? Oh, I just realized I need to, 1 second. Do this, and then let's put this here, and then we need to get in degree. But yeah, the best way to learn about, I think, is kind of just like, whatchamacallit. I guess if there's anything that I mentioned that like you're not really familiar about, first of all, feel free to just like ask in chat. This is all stuff that I'll need to be able to like, this is all stuff I need to like fully understand at some point, which means that I also need to be able to explain it. So, yeah, if I'm able, I guess it's also good practice for me. Second, you can also do a little bit of Googling. I think usually like the way something's spelled is on the screen, so yeah. Okay, so we want to get the in degree of everything. This is just like standard topological traversal order. So we want each basic block in basic blocks. We want to what I want to do, I want to get its descendants. And then in degree at cur or next, we want to increment. going wrong here? Basic block. Oh, whoops. Yeah, there we go. Good luck, thank you. Let's go try hard casual. Are you making your compiler memory safe? What do you mean by memory safe? Like, in terms of like not having memory leaks, like yes, that's just like good software design. But in terms of like checking the language, honestly, fuck it. We're just assuming correct input for the most part. I mostly care about the algorithms that do all the transformations, not necessarily like the error checking. Although that will be something that I add eventually, but that's not very primary. Okay, so we have this topological sort set up. The compiler, like, yes, I'm striving for no memory leaks, I guess. So the in degree goes up. And then, okay. Yeah, there should only be one entry point, so we don't have to like do another iteration pass through this, which is kind of ugly. Yeah, we have a work list here. And then all of this, by the way, is completely useless right now because we only have a single basic block because I don't have control flow. But once we do have it, I'm pretty sure it will be quite important. So we can do this for now. Yeah. Topology, yeah, that's what like topology and math is. I don't remember exactly if it maps like 1-to-1 for CS, but let me look this up real quick. Topological sort. Yeah, so it's like this. If you've heard of the LeetCode problem course schedule, where it's like you're given a bunch of edges in a graph, and then like, or you're given a bunch of like directed edges in a graph, and then you're basically asked to check if there's a cycle. It's kind of like that idea here. Yeah, I'll let you like look through this on your own though, but the idea is there's like a Kin's algorithm here, which is the big one that everyone like points at. And the point of this is basically we only explore each node once we've explored all of its predecessors. So that's where this in degree thing comes in. And the idea is first we count how many predecessors each node has. So that's what this upper loop here that I said doesn't do anything does. The reason it doesn't do anything is because we basically only have one node here. But once we do have more, that is how we will process that. So then what this loop will do is we start with the starting node. We process the node at the top of the work list, and then if that node is how do I explain this again? So we process that node, and then for all of its descendants, we subtract 1 from its in degree. So in degree is more like number of predecessors not processed. So we subtract 1 from each of its descendant nodes. And then if that value is 0, then we can add that to the work list because we know that all of its descendants have been processed. Yeah, that's like the very high level explanation of the algorithm. So yeah, that's kind of what we're doing here. So we want in degree at next minus minus. And then if in actually we can just throw this in here. And we can prefix decrement this. So if prefix decrement that is 0, then we can work list, we can oh wait, no, this won't work because we're gonna have loops. Oh. That sucks. Okay, never mind. We can't do this. Yeah, we can't do topless. Oh, crap. Man, I'm kind of a bot for not thinking of that. Okay, we'll just DFS then. Fuck it. Yeah. Yeah. So we can't do this stuff. So we can get rid of this. Descendants is with an A. It is an A. Okay. I see. Okay, so it is with an A. Good cons. Thank you for letting me know. Okay, so let's get rid of this then. Yeah, because this doesn't really make sense anymore, because if you think about how that algorithm runs, we literally cannot, we physically cannot traverse nodes that are in a loop, because their in degree will never be 0, because they're in a loop. So yeah, that would be problematic. Yeah, we might just do like a backtracky DFS of sorts, which is like fine, but it's like kind of annoying. Send dance. Okay. Let me that up there. They will never have 0 predecessors. Or I guess we won't get to a point where they have 0 predecessors. Yeah, because we only add them to the list if there are 0. So let's say we have like A, this goes to B, and then C, that goes back to D, and then that goes back to B here, as an example. So initially the work list is just A. So we process A, and then we check all of its descendants. So that list is just B. And then we subtract 1 from its in degree. But the problem is that will never be 0 because we can't have process D at any point. So I guess like in degree of A is 0, so that is in the work list. B is 2, C is 1, and then D is 1. So we start at A. So this is the work list. This is in degree. So we start with A, we process that, this is done. So then we subtract 1 from the in degree of B, and this is 1. But we can't really add anything back to the work list because all of these are 1. Yeah, that's the brief explanation. Yeah, it took me a little bit to figure out why that was working. If you want practice with that specific pattern, just look up course schedule on LeetCode, and you will have a lot of hands-on experience with it. But yeah, bottom line, this thing I did doesn't work, so we need to figure out DFS. DFS. What's up, Janine? I got pinged. Nah. Feel free to ask other questions as well. Yeah, I think that's fair, Carter. I think it's really easy to like think. I guess like it's misleadingly enjoyable at some points, but like there is just a lot of churn that a lot of people don't mention. Oh, actually, this gives me an idea. I think I know what I'm doing here. Michael's asking if you want to get the Guzman deal. Let me check when it closes real quick. Sorry. I don't have the app anymore, damn it. Alright. Oh, it closes midnight, yeah. Let me say yes real quick. Okay. Thank you for reminding me, Ginny. Okay, so... yeah, I guess we do just have to like DFS all the way to the end. Well, we can also do it with a visited list, actually, now that I think about it. Yeah, we can do it that way. Yeah. Sort of. Let me kind of draw it out. How do you know if you like to code? If it's something you're willing to do in your free time, just independent of any other incentive. Like if you enjoy, like if you're willing to write a personal project just for the love of the game, then I would say yes, you do enjoy coding. And this excludes doing things for the express intent of resume. So this example I'm thinking here, let's draw a graph. D, C also branches out to E here, and then these reconverge at F. And then this also branches. Let's make this complex. So I'm trying to figure out like how we would iterate through this without having like I guess many duplicative paths. So what I'm thinking is so we're assuming we have like fees already inserted, so that's like reconciling two variables in the previous node. So which ones would have fees? So D would have a fee, these would not, E is straight line, F would have a fee. Yeah, okay. And that corresponds with like in degree stuff, so yeah, okay. What do we do? So let's assume like pre-order, is that the term? Yeah, pre-order traversal. So we process A, then, okay, so my idea here is then we process B, and then we can process D once. And then its descendants are G, so then we process G, then we process F once, and then we'll have to process those again. Yeah, because a fee gets constructed here and here, I guess, which I'll save explaining for now because that is like a whole nother can of worms. I'll explain that once I have like if statements, but that'll be a while off. But I promise this is like important for a reason. It may be a little bit cryptic right now, but just trust me here. Okay, so then we explore C, and then, oh, but then we have to worry about like this. Because we wanna visit each of these from each of its in edges, I guess. There's probably some like really trivial algorithm that I'm like missing. Maybe I should make these like two-way, because then we can like kind of get predecessors. I don't know. We'll worry about that later, but yeah, so we visit D the second time. G's already explored, so we can omit it. Yeah, and then if the current is, if the current's been explored once, then we don't explore its children. Yeah. Yeah, okay. So we want, let me just type this up for myself. So preorder traversal, and then we want, so what do we need to keep account of? We need to keep account of, I guess we do need like in degree, which is kind of funny. Oh, you're right. I didn't account for loops. Okay, we're gonna backtrack for a second. Sorry about that. Yeah, we can't actually do tree traversal here. Just occurred to me. Yeah, E. So then we have F. Let's make this go back to B as an example. Yeah, let's do that. Yeah. So preorder traversal is still like a very much a yes. Each basic block, we want to visit what do we visit? MD, that doesn't work because then we can get into a cycle. We can just get stuck between nodes B and D in this example. Yeah, it can be cyclic because like while loops, for instance, or for loops. What do we want to visit at each? Oh wait, this is still the same. This doesn't change the algorithm actually. Just visit children if cur BB hasn't been. Yeah. Anyway, so if not visited, so if it hasn't been visited, then we want to just like do the normal stuff. So process the basic block and then visit children. The thing is, we also want to visit some nodes multiple times because of like the whole fee situation. I don't really want to get into the explanation right now because it's not particularly relevant, but this is just for like structuring. so if visited, then we can just update fees, I guess. We can do that. Okay, so we start at A, we visit B. We visit B once. So then we visit D once. So this is the first time so we visit A. So we visit B for the first time. We visit D for the first time. So then let's just get E out of the way first. E has no children, so we go back up. So then we visit B again. Yeah, so then we avoid the cycle because we visited it once, but we still need to add, like, we still need to like account for the fee. So we update the fee here, we go back, we can go back up, we go to C, it's been visited once. We get onto D, we update the fee, we go back. Yeah, I think we've done it correctly. So then we go to E and then we go to F, yeah. So each of these has been visited number of edges times, I guess. Yeah, okay. This seems reasonable enough. So given this little thing that we've written, oh boy, this doesn't fit on the screen. Yeah, so I'll just move this to my second monitor. Apologies, y'all. Okay. Also, this is wrong. Whoops. Also, if we're doing DFS, this means we should be using a stack, which is also a deck, so it doesn't matter. Okay, nice. Okay, so we get back, and then yeah, so we process this one. We should have a visited set. We want a unordered set. Is there ever a reason to use it? Yeah, okay, well, sure. So unordered set of basic block. This is visited. Oh, we need to import. There we go. Yeah. So we can, yeah, so this is the starting state, and then so we pop back and then process the current one, and then not visited dot find contains. So if it doesn't contain the current basic block, then we want to do things. Or we could do it the other way. We can do continue. Welcome to the stream. Oh, what? Never thought I would see Novum Windows on a stream? Yeah. My laptop runs Arch, but I have a Valorant addiction, which means I still need Windows on something. Okay, so otherwise, then we want to add its children to the work list. Are you ever gonna stream Valorant? I've streamed before on Twitch, actually. All of that's still public if you wanted to like look through it. Yeah, it's up to you. I'm not gonna be. It's up to you if you want to look at that. I won't be streaming that on YouTube though. I want to keep my YouTube stuff strictly coding related. So auto. Are you following a book or something? No, this is completely just like me going off of like the general knowledge I have, and then maybe like referencing a few things here and there. Drawing heavy inspiration from whatever infrastructure LLVM has, at least. That's why this pass is called mem2reg, and why we have like passes and a pass manager. Let's do one auto next in cur.getDescendants. Do you think your channel is a good thing to list on your resume? Honestly, I'm not sure. I don't think it hurts, but also like I don't have a reason to, so okay, so these are actually separate. It just occurred to me. So here we want to, so we can process there. Here we want to add to fees. Oh wait, we only want to process if it's not. So this we visited once, so we just want to update fees. Process basic block itself here. Yeah, I think the fees would have to be at the top anyway, so I could just keep them separate even. Yeah, so we can process this basic block. That would go inside here. No, it'll go up here. And then here we just add the descendants. So work list dot push back. Next. Do that. Yeah. And then yeah, that should be everything, actually. So now I need to like actually do the variable renaming in here. Yeah, this is gonna be a mess. I don't know how to do this without making a billion copies, I guess. So I guess we go back to the SSA book. As always, our favorite. Where's the renaming algorithm? There it is. Yeah, so it'd be this stuff. Talk us through your thoughts? I don't got any thoughts right now, low-key. I'm kind of just figuring out what's going on. What are you using to draw? Paint.net. It's Windows only though, so. Or it might be on Mac, I don't know. Oh wait, I've literally accidentally discovered this. I've accidentally done this distinction. Are you documenting this journey? This is more just so I'm consistent about working on this every day. Yeah, I haven't used a Mac for writing code yet, just because I haven't had a reason to, at least. Presumably they're pretty good though. I've heard a lot of good things. I've heard a lot of bad things about just Macs in general, but that's completely different. What is SSA? I'll explain that after I at least get some of this written out, I guess. So it'll be like a little bit of like, it'll be a little bit of just like trudging through the dark, but like trust me here. Okay. Okay, so now we can iterate through the instructions, which is what would be here. So we want each instruction, incur the instructions. So the definitions would just be allocates, I think, right? No, wait. No, that would be... I mean, this is just gen and kill sets. Okay. So the uses is straightforward apparently, because question mark. Let's go this after, yeah. We should have fees already inserted in theory, so we can iterate through this. Yeah, we should keep like a current mapping thing somewhere. I might just be overcomplicating it for myself by trying to go strictly by the book. It might make sense to just to just kind of do this on the fly. Yeah. I think while we insert the fees, I think we can process the allocates. Maybe? Yeah, I'll just do it here for now, but there might be a point where it makes sense to move that out. So we want I need a map, Lamau. So this goes from the allocate to the current value, I guess. Yeah. Okay. So this goes from value putter to number. Number? No, this goes from allocate instruction to value putter. So this is clear value. I can do that. What's your favorite distro other than Arch? Well, I'm running Fedora on this, so I guess Fedora, WSL. So I guess Fedora would be my answer to that. Advice for anyone who wants to get into coding and be patient. Yeah, I mean, I guess just like, I think the advice is the same as just in general. I think just like, just make things with your own time. That's the best way to learn, and that's also the most rewarding work, at least, rather than just like following tutorials forever. You wouldn't need a high-end machine for compiler stuff. Like, this builds perfectly fine on my laptop, at least. It might just be like a little bit slow, if you were to like build an LVM. Like compilers in particular, because I think they're cool. And front-end work, it feels very dry to me, and back-end just feels like, it feels like if I'm doing back-end, I may as well like work on compilers at that point. So there's 3 types of instructions here we want to handle. We want to handle loads, we want to handle, we want to see if it uses. Hey. This sucks. This really sucks. Yeah, this is really difficult to do with just like stack variables, to be honest. So if it's an allocate, we want to keep the pointer. If it's a load, we want to replace uses there with the value in the thing. We couldn't even just skip the allocates then, because the default value will be like null putter. Yeah. Maybe we need to set it. So let's do auto. So we want allocate equals dynamic cast to allocate. And then we want to feed it I guess. I don't get. Yeah. What? What's going on here? Oh, putter. Yeah, we'll have to do a little bit of gross dynamic cast stuff. Also, I just realized this is a little bit hard to see, so sorry about that. Let's just move this all here. So we do this, and then if it's not a null pointer, I guess if it's not null pointer, so with that, then we can curval. So curval at allocate will be null putter. Yeah. And then I don't think there's an instance where this can dynamic cast to all of them, so we can even just keep this ugly tree going. so this will need to be load. I might need to make a visitor for this. God damn it. Yeah, okay, well, wait, let's get this done first. Let's see if we can do it this way. With load, then we can do something. And then one more. Store. Okay. What else are you on? I am on Windows right now, but I'm using WSL Fedora because I enjoy being able to write code like a normal person. I think Neobim is quite fine for C++, just as long as you're willing to like not have like proper IDE support, I guess, if that makes sense. Because it is just a text editor at the end of the day. Are gonna build an OS? We'll see. I will be, I'm actually taking OS this upcoming quarter, so I guess I will do a little bit of that. Yeah. Maybe I'll make a programming language at some point, but I don't really have a reason to yet, I guess. So how do we handle load? Load will update the value. So we want val at load will equal this sucks. This doesn't make sense. No, this would be store. This would definitely be store. Let's make this curval at store would be no, this is not quite right. You need allocate dot no, wait. Get footer? Yeah, that would be to the allocate, so that would be right. So we can set this to get value, I guess. Yeah. Okay, so this is that. That should be an allocate. Right? I think that's how I wrote it. Maybe I can make this more expressive. Right, and then real quick, let's see if this builds. 16 or 32 gig, as much as you can get, usually is good to go for. What's going wrong here? Yeah, the putter should be an allocate, I think, if I did this correctly. Okay, we're gonna take a quick break from this, just to make sure I did all the other slash correctly. This would live in here. So we want store. Some value mappings. What do compiler programmers do on a daily basis? They work on compilers, I guess, yeah, they write optimizations, they work on new language features, so on and so forth. How to know if you like compilers? A good start is probably just like writing an interpreter, following like the crafting interpreters tutorial. If that's something that you're like, damn, this is really cool, then like maybe this is something you'd want to work on as well. Okay, so it would probably be under declaration. Yeah. Yeah. Yeah, so that does have to be an alloc. So I think we can safely update the putter to an alloc. Yeah. Do that, and then yeah. So then down here we can also make this a instruction alloc. So store and load have that. And then the constructor I think we need to change. And then up here. Yeah. So then some things we need to change here. This putter is instruction alloc. Do I need to change the getter? Oh, I already did change that. So this is good, this is good, this is good, that's good, that's good. Okay, I did change everything. Good for me. So this is also an alloc. We can use the tilde. There we go. Okay. So let's try rebuilding it. Oh, it doesn't let me do that. Why doesn't that let me do that? Where does this come from? Load. Oh, I need to dynamic cast then, I think, right? Or I need to just straight static cast it, even? What's going wrong here? Value mappings. Where do I make this? HR to MR, I see. Wait, so that'd be here? Value would be... yeah, it'd be like that then, right? What's wrong here? So this would be instruction allocate. And then this would be and this would also be instruction allocate. Right? Does that let me do that? Was there a reason that I didn't do that? Okay, so then applying De Morgan's laws, yeah, that'll probably go under like my general instruction combined paths, along with things like constant folding. I guess maybe just like it falls under the broader umbrella of canonicalization. Yeah, okay, I think this should be fine. Looks like nothing's breaking yet. Get descendants. Oh, I didn't implement it yet. Whoops. So that would be under here, under basic block, yeah. Let's do that. Okay. So let's rebuild this. Do the test run. Okay, so they still pass. So that was a correct change to make, actually. This sort of narrowing. So let's clean up some of this real quick. So yeah, so this one we, oh, whoops. Let's diff these. Yes, I'm correct. Yeah, okay. So let's add those. And this is add base log descendants to MIR. And then what else do we need to add? We need to add instruction. So what do we do here? We replace putters, or I guess like made putter values more specific in load and store. Damn it me. HR to MIR. Okay, so that's some of the changes, and then now we can finally go back to why I wanted to make those changes. which is here, yeah. Yeah, because we need to make sure that this is an alloc. Wait. Oh, it was down here, right? So the putter has to be an alloc. So then we can... wait. Yeah, because this map is of allocs. So we needed to guarantee that that's an alloc and not necessarily any other value. So that is why, I guess in this block specifically. So store makes sense. The allocate itself makes sense. I'm not really sure what to do with this load though. What is a compiler? It is a program that translates one programming language into another, roughly. So what do we do with a load? I mean, we could just iterate through the rest of the instructions and then set its value, I guess. Yes, transpilers are a subset of compilers, I would say. I don't think it's really a distinction with much of a difference. What other cases do I need to handle? Okay, let me go back to this big algorithm. I'm getting lost in this sauce, at least. Let me read back through this. To obtain the desired property, it's necessary to perform variable renaming, second phase in the essay construction process, function insertion, blah, 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 blah. It splits the live ranges. Okay, that makes sense. Oh wait, this allocate stuff is like for nothing. I think I just realized, but it's like kind of messy. Yeah. Okay. How are you handling tokens? This is all in the front end. This is handled by the parser. So this is both a lexer and a parser, I guess. But it's just one big parser generator. I don't think it's really that interesting. If you want to give this a closer read, the code is all on my GitHub. Yeah, and then this is like the handlers, I guess, for the parse rules. Why aren't you doing push for the lexer? What do you mean? Almost everyone's jumping on the Gen AI wagon. How'd you end up choosing compilers? I took our university's compilers class on a dare, and it turns out I really enjoyed it. So here I am now. I feel like I am making this too complicated. Handle this. Because like I think the obvious choice is just like keep a map at each basic block, but that seems just very memory expensive. Like, presumably there's a better way to go about it. Well, you know, maybe I just do it that way. As the programming languages people say, memory is infinite space. So maybe I just do that, but I'm really scared of that being slow. And I wonder if there's a better way to do this. You know what? I want to throw this into ChatGPT, honestly. I don't really see any good way to go around this. Let's just steal all that. Yeah, for better or for worse, I'm gonna need to do this. And then let's change the stuff in here. That. Let's just also get rid of curval for now. How do I do SSA construction with stack variables? Yeah, because all of the books, from what I've understood, either they assume like SSA construction just from like normal variables, but none of these really account for stack variables, I think. So an allocate is like a virtual register. Stores, yeah, and then fee insertion I'll do later because I don't have control flow yet, so there's no need for it yet. That will be a future issue. Oh yeah, okay. Yeah, I will also have to change the allocate creation for variables in the future. I'm writing my own language based on Holy See. What fun, what joy. Let's go to the last bean bender. Okay, so this roughly makes sense. Generate a new vibe coder. I'm trying to do it as little as possible. You should learn lambda calculus. I've like looked into it a little bit, just from like a PL perspective. It seems really cool. Something about I swim. Wait, what? That makes sense. This would also only be an entry. So then SSA definition. Sure. This is the wrong book, by the way. Okay, and then I can kind of just... Yeah, I'll just do the cleanup at a later point, I guess. We can just make a kajillion extra variables, and then we can do a cleanup pass as well, I think. That might be like the reasonable way. So then what is a store? What is a store? What is a load? Oh, wait, duh. Okay, wait, I see. Okay, wait. No, this makes sense now. This makes sense. This completely makes sense. Okay. So allocate, I can just ignore for now. I think. Okay, I'll just comment this out then. I hit the wrong key. There we go. And then this load, we want to oh, but we don't have like straight assignment. I don't even have like temporary registers in this. Or it's like virtual registers. Oh, so much has happened, chat. So many U64? Yeah, I like big numbers. Yeah, I don't really know any other good resources for, I guess, converting stack variables. Actually, let me just Google this. Stack variables. Oh, this doesn't help me. Maybe I should just look at LLVM's code, but yeah. I'm enjoying C++. I don't know about y'all. It feels so dangerous, so dangerously efficient. Who knows what happens when I start writing C code. Oh, well, I need virtual registers anyway, just because, like, function parameters. How can we test this? You have piano in the background? Yeah. I do play piano from time to time. What do you think of Linux? I think it's great. I'm only on Windows because I play Valorant. Let's look at memtrudge. Let's just look at memtrudge. I think this will be less miserable. This probably lives here if I had to guess. Let's. Surely this is in lib. And this would be transform. Can you search up the derivative rule? Oh, for multiplying two functions, derivative of f times g is f times derivative of g plus derivative of f times g, I think. It might be a minus, might be a plus. I think it's a plus. Is this in here? Oh, I need to look at that eventually anyway. Utils? Surely it's in here. It has to be in here. Yeah, there it is. Okay. So this is the part that I care about here. So for allocates, we get the entry block. And then, why is this a while loop again? Oh. Wait, what? So for each basic block, if it's an allocate, then if it's promotable, does that exist here? Is allocate promotable here? No? Okay. Well, if it's promotable, then we can push it back. And where does this come? Oh, that's where it's from. So allocates, we need the dominator tree, and then we need, what is AC? Assumption cache. Okay, so this seems like the wrapper, and then where does this come from? Down here? Oh no, okay. Okay, this is where everything is. Oh lord. So this is sure. And then, oh god. I'm really looking forward to this. Really looking forward to implementing this. Okay. Promote mem to reg, and then are we gonna like actually find the thing? Can you like go all the way to the bottom? Okay. Promote mem to reg. That is, no, it's not that. I know it is that. Wait. Dot run. Okay, so it's this. So it's this. This is actually the thing. So sure. I feel so out of my depth right now. I don't know what's going on. A single store, just directly replace. It's only read and written in one basic block, linear sweep. Oh god. Keep the reverse mapping. Jesus. IDF? Anyway. Instruction data flows. So this inserts fees for that allocate. And then well, this is not helpful. This is very much not helpful. I can't tell what's happening. Okay, so we've like inserted fee nodes. And then god damn it. Poison. Okay, yeah, this got me nowhere. This is so dense. This is so much stuff to figure out. Gonna take computer programmings for your electives. Yeah, I think that is what sparked my interest for some degree. What's good, Aiden? Good to see you here. You've caught me at a time where I am doing a lot of reading and a lot of thinking, and not really a lot of writing. How long have you been coding? I've technically written some code in high school, but most of my substantive code was like about my first year in college. Is compiler development in Rust hard? It's probably easier because there's less stuff to worry about. I need to worry about food real quick. Oops. Sorry, give me a second. Yeah, okay. Okay, well, this sucks. Where would you say is a good start? Either one of the big compiler books, or if you haven't gone through like crafting interpreters, or if you haven't like written any semblance of an interpreter, I think that's a good place to start. It gets you thinking about like parsing and just like generally traversing through a program, which I think will make everything else easier from there. Okay, so we will just have to do this the lazy way, but yeah, so what we're gonna do is we're just gonna add a virtual register sort of thing to values, I guess. But I don't like that solution either. That seems very clunky. How do you ensure that code with different formatting runs the same? You in the parser, you just skip white space. That's roughly it. Join your Discord, thank you. That's also a good time for everyone else, or for me to plug this. You should go to the description and join my Discord because that's the best way to get pinged when I go live. Yeah, best way to get pinged when I go live, and also chat with other people of the community. Okay, so I think the only way to go about this without just like having to worry about like this algorithm for now, because I don't really know how to make this work with stack variables. I think it might just have to be wait, am I stupid? Wait. No, wait, I am stupid. Uses correspond to loads. And then variable definitions correspond to stores, I think. I think that's what's happening. See you, Niraj. Okay, so then, so we need to update the reaching definition. at the load and then update reaching so reaches I and then so we want to do this in the other order, I think. Right? Replace use okay. This is like I'm like so confused here. This shouldn't be okay. Okay, let's just write this in comments for now because I do need to go soon. So we update at b equals I and then replace so the allocate reaching definition is I and then replace use of so we replace the use of allocate in next instruction with I. And then store here, we want to oh god, okay. The allocate is I. We're finally making progress, I feel like. This might just be like fake progress, but yeah. We make a new variable. How the hell do we make a new variable? We don't really have variables here. Wait, this is doomed. Create fresh variable B. And then place defin of okay with wait, no, we make the variable already. We literally make the variable. And then, wait, so then we just... So this is done. We replace definition of the allocate with... This is done. So then reaching definition of the new variable equals definition of the allocate, I guess. And then, wait, what? Wait, what? Was? So what is this update reaching definition thing? then is that next page? Oh, it is, okay. Let's do that, I guess. Then we can, so we can go back here, and then pushing definition of the OK equals V. Right? Yeah, okay. Okay, that, yeah. Yeah, that seems about right. What companies pay for compiler development? Apple, NVIDIA, pretty much the rest of big tech, actually. The list goes on. Yeah, so... Okay. Okay, I need to... What happens here? Search through a chain of definitions for V until we find the closest one that dominates. Then update in place. Okay, well, I'll just leave this here for now. This is gonna be a tomorrow me issue. I'm quite hungry, so I'm gonna call the stream here. Let me just add this. I don't know what changes I made to Pass Manager actually. Ah, I see what I made changes to. Commit. What are you gonna eat? I'm going to get tacos with a friend. So this will be Mormon, 2-inch progress. Plain format, damn it. Okay, well, okay, sure. Yeah. So, thank you all for tuning into the stream. Yeah, make sure you like the stream and sub to my channel if you haven't. It really helps get my content out to more people. And while you're down there, you should once again join the Discord. That is really the best place to chat with other people in the community and to, I guess, also chat with me when I'm offline. It also is the best place to get pinged when I go live. And you should connect with me on LinkedIn and add me on GitHub. And yeah, if you know anyone that's working at a place that needs a compiler person, send my resume their way. So, take care all, take it easy, stay hydrated.